Today we're looking at lesson 7-8, which is recursive formulas. A lot of times we've already worked with what they call explicit formulas, which is basically a formula that's given and then you plug in a value for the variable to find the next variable or the next sequence of variables. The difference between an explicit formula and an explicit formula, unless I just said the same thing. The difference between an explicit formula and a recursive formula, is that an explicit formula gives you the formula, you plug in your value for your variable, you find your next term. In a recursive formula, you're plugging in your value for your variable, but then you're also doing an operation to that value to either find the value before that or the value after that. So you can find multiple values in a sequence, and you're also performing more operations to the actual formula. So here, in terms of a definition, a recursive formula allows you to find the nth term, just like an explicit formula, of a sequence by performing operations to one or more of the preceding terms, which is the ones that come before the first term or that particular term that you're trying to find. So the first one, we're going to be given the formula. This is your recursive formula. Notice it looks kind of like the arithmetic sequence formula, and a sub 1 is your first term, just like the arithmetic sequence formulas. So our first term here, if we're going to find the first 5 terms, our first term is going to be a sub 1, which is -2 they give us. And then our recursive formula that we're going to use is a sub n equals -3 a sub n minus 1 plus 4. And it's giving us the fact that n has to be greater than or equal to 2 when we're plugging this in. So the fact that it says n has to be greater than or equal to 2, that gives us a starting point. So besides our first term, we're now going to start with plugging in 2 for n, and we're going to find our next term. So if I plug in 2 for n, I have -3 times a sub n minus 1, or a sub 2 minus 1, and then that's going to give me a to the 1. So I have 3 times a to the 1 minus, or plus 4 in this case. So a sub 1 was -2, so that's what we're going to put in for a sub 1. So we have -3 times a sub 1, after we plugged in n is 2, plus 4. So we get 3 times, or -3 times -2 plus 4, which is 6 plus 4, or 10. Then we're going to do that again. So we're going to plug in for our next term. Since it's going to build on the 10, we're going to plug in 3 for n. So we have -3 times a, and then 3 goes in for n, plus 4, like this. So if we simplify, we have -3 times a, 3 minus 1 is 2, so that's a sub 2, plus 4. And what was our second term in the sequence that we just found? That was 10. So we're going to plug in for a sub 2, 10, plus 4. So we get -30 plus 4, or -26. So that's our third term. And then we're going to build off that. So the next one, we have -3 times a n minus 1 plus 4. We're going to plug in 4 for n, That gives us 4 minus 1, or 3. And now we're talking about the third term in the sequence, which was negative 26. So that's going to be multiplied by negative 3, which gives us 82 once we add the 4. And we'll do that one more time for the fifth term. And plug in 5 for n. Oops, that's an n, not an a. 5 minus 1 plus 4, so negative 3 times a to the fourth power, or to the sub 4, plus 4, which is your fourth term, which we got was 82. So negative 3 times 82 plus 4. So notice that the sequence is building on each other. It's not necessarily by itself every time. So this becomes negative 242. So we have all 5 of our numbers in our sequence. But they all built off of each other to get that. Next one we're going to do is we're going to build an actual recursive formula, or we're going to write it. And there's a 3-step process to do that. So we're going to follow this step-by-step process. There's 3 steps. The first is to determine if the sequence is arithmetic or geometric. We already have talked about arithmetic sequences, which is going to have a common difference. A geometric sequence is going to be a common ratio, so more of division of itself. So we're going to look for the difference there in our examples, arithmetic or geometric. And then we're going to use the recursive formula setup. An arithmetic recursive formula is what we just did, where we have a sub n equals a sub n minus 1 plus d. D is your difference. And the geometric recursive formula setup is a sub n equals r times a to the n minus 1, which r is going to be your common ratio. And then the third step is going to be to state the first term and then the domain for n. So we're going to take each of these and do the 3-step process. And the first step, if we're given a sequence, let's say we have this sequence, is to determine either the common difference or the common ratio. So we're going to subtract the second term minus the first term, and then the third term minus the second term, and then the fourth term minus the third term. So 10 minus 4 is 6. 25 minus 10 is 15. 62.5 minus 25 is 37.5. So this is clearly not a common difference situation. So we're going to have a geometric sequence, which to get the geometric ratio, we're going to have to take the second term and divide by the first term. So 10 divided by 4, which gives me 2.5. And then the third term divided by the second term, 25 divided by 10, which gives me 2.5. And then the last term divided by the third term, 62.5. 62.5 divided by 25, which also gives me 2.5. So you can see that there's a common ratio here. Which tells me that it's a geometric sequence. So we're going to use the setup a sub n equals r, which is our common ratio, times a to the n minus 1. So we're going to plug in our r in our equation, which is 2.5. And we're going to keep the a and the n minus 1 the same. So there's our equation. With recursive formulas, no matter what kind of sequence they are, they're always going to be n is greater than or equal to 2. And then it also asks for, notice it asks for our first term and our domain. The domain is what I'm talking about there with the n is greater than or equal to 2. The reason why it does that is because if you have n minus 1, if you do anything that's less than 2, you're not going to get an actual term number. You're going to have a sub 0, which wouldn't make sense. We always want to start with a sub 1, which is our first term in our sequence. So we're always going to have our domain be n is greater than or equal to 2. And then our a sub 1, which is our first term in our sequence, was given to us. That was 4. So this would be our answer. The next problem we're going to do is a word problem, and we're going to kind of use the same step-by-step process here.